Hi, everybody. It's Emily. So, a lot of folks have a Presidium II gem tester, and I just thought I would make a guide for how to get the most accurate readings from your Presidium tester because it's a tool, and tools only work as well as the person handling them. It's not a guaranteed read. These little bits here are not actually a guarantee that it is what it says. What the Presidium does is it reads heat displacement. It reads what's called thermal conductivity. And then it is calibrated so that it has this handy little guide here that shows you the ranges in which these different gemstones, what their range for thermal conductivity is. If they didn't have this little dial and the little bars, it would just have numbers on it to show you that. And then we'd have to look up those numbers ourselves in charts. So it's a tool. It's not a guarantee. You need to know other information about the gemstones that you're looking at in order to really have a confident feel for identifying them. So the first thing that you really need to do every single time you turn it on is you calibrate it, because it works off of temperature. So that means that the temperature of whatever room you're in affects the readings. So when you from using it at your office to using it at a thrift store or a bedroom with air conditioning or wherever, that affects the readings. And even just using it from day to night can affect the readings. So it turns on, this light blinks until it's ready to go. And when you're going to calibrate it, on the side, there's this little plug, and they come with a little pin that you can use for pressing these buttons. I always lose the damn thing, but any long type pin can work. I'm literally using a pin, like a sewing pin, because that's what I have. But you could use like a straightened out paper clip. It's fine. So we're going to wait for it to stop blinking. And it's blinking to tell you that it is heating up, because the way it works is that the little metal probe right there on the end of the pen heats up. And when you press it into a gemstone material, the tester reads how quickly the heat dissipates from that little wire to the material. Okay, so it's warmed up now. So what we're going to do is it doesn't matter which one of these you push, but we're going to push down one of the buttons in there, and you heard it beep. So now we put it down and see how it's blinking blue. You're going to use the cal disc. And when you use your pen, you want the flat edge of you want the tip of the pen to be completely perpendicular to whatever you're testing. So straight up and down. You want this flat edge to be flat against whatever you're testing. I have to get it set again. So we're going to just hold it on the cal until it beeps at us. And green means glass. So we're going to use the glass one. And then you just follow what it tells you to do. So it's going to have us do the cal 2 more times. And now it's red and it's done. And it wants you to wait a couple minutes. I believe the manual says 3 minutes after you're done calibrating it. But in the meantime, some tips and tricks about getting your readings. So the way that you use the probe affects the reading. Remember how I said it needs to be flat? All right, focus. Come on. There it goes. So you want it to be flat. You want to find the largest facet you can on the largest stone that you can, and you want to be flat against that facet. And that one is going, you can see, all the way up to ruby, and I know that this is a ruby. So that helps confirm. But see how it's flat on there? That's very important. Watch what happens when I hold it at an angle. Or I don't push all the way down. See how it doesn't read as far? It doesn't read as far because it's affecting its ability to transmit heat. And when you use a smaller facet, it also affects its ability to do the reading. See, it's a smaller facet and I'm still flat on it, but it's not able to go as far, and it didn't go all the way as far. A smaller stone will also have a lower reading because it doesn't have as much space, literally physical space, physical surface to draw away the heat. These ones are easy though. These are littles, and because they're little, I know that they're reading kind of low, but when I shine a black light on them, they glow. So I know that they're rubies and not topaz. But because they're little, they have smaller facets, they can't dissipate as much heat, so they test lower on the device. Anything that you get wrong is basically likely to give you a lower reading on your Presidium. Same thing with using rounded. That's not too bad, actually. Using rounded gemstones is harder. You're basically going to get a lower reading because you don't have a flat surface to use. This one isn't too bad. So if you're doing something flat like a cabochon, not flat, round like a cabochon, you want to try and find the largest, widest, flattest part of it that you can. And again, you're just gonna hold it as flat to it as you can. And it's going just under quartz and amethyst and citrine, which I know that this is a moss agate. And moss agates are a silicate, and silicates test in the quartz range or just near it. So that confirms what I'm looking for. Mostly, a Presidium really isn't for telling you what a stone is. It's much more, well, unless it's diamond and moissanite. What it's much better at doing is telling you what it's not. So this just told me that it's not glass, which is the only other thing it could really be, because I know enough of information about various stones to know that this is cold and hard, so it's not plastic, and it's either glass or a moss agate, because there are no other gemstones that look like this. And for this one, because of the color that it is, I would be looking at gemstones. I would be looking at glass. I would not be looking at cubic zirconia because it's not rainbowy enough, like it's not fire enough, and it has inclusions. So I would be looking maybe at glass, but I'd also be looking at tourmalines and maybe garnets and spinels and topazes. So when I tested it, it definitely did not test in those other ranges. It tested in the ruby range, way high up. And then I can confirm it with glow. Not all rubies and sapphires glow, but it's a useful characteristic. So when you're testing something that has a rounded edge, like, it's a cabochon, just remember that it's going to give you a lower reading than what it would give you if it were a flat edge, a full facet. If you can reach the back, like if it has a flat back and you can reach it, that can be a good place for testing. See, I'm completely flat on the back and it got as high as it's going to get. And also, when you use a Presidium, you don't want to use the testing result for where it settles. You want the highest point that it reached. See how it went down a little bit, but it started, like, it got up to about there. That is actually the reading that you want, because heat dissipates over time. It's important information. Glass does move because there's different kinds of glass. If it doesn't move literally at all, it's probably, it's not a hard material like glass or stone or even some ceramics. It's something like plastic or jet or amber or maybe even a super hard wood or resin or bakelite or whatever, that kind of thing. Glass moves. I'll see if I can get it to zoom in. There we go. So, that right there. This is glass. I know this is glass. It's old. It's in terrible shape. It's antique. Someone flipped it. I can tell by the way that the cuts, the chips are, that it's glass. But if I test it, the needle moves just a little bit. Come on now. There it goes. It moved just a little bit, a little teeny bit, but that tells me that it's glass. And that's important. Let's see what this one is. This purple one. Okay, see, that one's glass. And the other thing that I would have thought it might be, it's not, it doesn't, it's more purple in real life, but it's sort of a smoky with a faint purple tinge. The only thing that I would expect that it might be if it was a gem is some kind of quartz, but it's not, it's glass. These little ones, those can be really hard to test. Just do your best. They often, the dreaded beep, that means you touched metal. They're often glass. Let's see if I have something that's labeled CZ. This isn't labeled CZ, but it's pretty sure it's a CZ because see how sparkly it is? Like it's rainbow sparkly. It's ultra sparkly and also it has a rainbow flash in it. That's a good sign that it's cubic zirconia, even when it has color in it. They can make them in any color. They don't come in just white. Super ultra sparkly. Like absurdly sparkly. Weird colors that aren't real. So rainbowy. Pristinely clear. It comes out just above glass. Actually, a little bit above glass. That is pretty mid-range consistent with cubic zirconia in my experience. Cubic zirconia has a pretty wide range of testing. depending on size and also quality of the zirconia. I've seen it pretty far up, but basically its other traits, the sparkliness and the rainbow shine, lead me to believe that it, like, a quartz is never going to have the ultra rainbow sparkle. I don't see large enough cubic zirconia test like in the bulk of the glass range if it's sparkly, and especially if it's clear, like colorless and sparkly and with rainbow glitter, and it's testing very solidly in the glass range. I am much more likely to think that it is leaded crystal. Just like the kind, like, Waterford cut crystal, that's leaded crystal glass. And they do use that for jewelry as well. And that has been used for jewelry for a long time. The other thing that is important, going back to temperature, about your readings, is that if you have a breeze blowing on you, it affects your readings because it is pulling the heat away from what you're doing. So watch this. I'm gonna put a reading on this, and then I'm gonna blow on it. So I'm just watch the dial. So we've got our normal reading. Hang on. Oh, because I was cooling it down. But so literally when I just blow on the probe, it causes the dial to go up. So if you have wind blowing on you, that affects your reading. I find that it typically causes your reading to be higher than it really is, but it's going to be inconsistent. So you need to shield yourself from wind, including like the breeze that's coming from your air conditioner or a fan. Again, and one last thing that I've noticed when folks are reading these, some folks think that the name on the black bar that it's in for the range indicates like it has to be that range. So like ruby is right here, like under, if the needle falls to the word ruby, that's a ruby. But if it falls over here, it's a sapphire. And so like if it falls down here, it's jadeite. And if it falls here, it's spinel. No, this means this black bar is the entire range for the words that are above it. So if it's here and it has characteristics of jade, it's a small crystalline or amorphous crystalline, very fine-grained stone without a real visible like crystal structure, and it's mostly opaque, slightly translucent, and it's the colors that you find jade in. It's jadeite, not spinel. Quartz, amethyst. So like if the dial goes all the way here, that's not a citrine, that's a topaz. Because see the black bar? Topaz bar. Citrine is within here. Although I typically find that citrine does test all the way to about here, and it has something to do with the impurities that make citrine. So it's just something that goes to show that this doesn't give you easy answers. It's a tool that you use with the knowledge that you have to help you identify the stones you're looking at. So just because it falls in here doesn't necessarily mean it's a tourmaline and not a garnet. So there you go. Let me know if you have any other questions.